Hey everyone, John Harper here, founder of Hackers Teaching Hackers, back with another solve video. This time we're going to be looking at MovieSQL. So let's go ahead and get jumping in. So MovieSQL had one solve during the conference. Shout out to Icarus in Discord, also known as Team The Choppa in the CTF. And we had at least one solve post CTF. Shout out to Suits there for working through that with me. So good job on that. It's definitely solvable. We had some issues in this one that we kind of, not issues, but we discovered that if you tried to solve this one using the graphical user interface of SQLite, this would definitely not work. And I will cover all of that in this video so you know why that didn't work. But let's go ahead and jump in. So MovieSQL was part of miscellaneous. It was worth 500 points. So definitely a biggie. The reason we went with 500 points on this one was because of the heavy lift that is required. This challenge does take advantage of multiple different types of encoding. It does also take advantage of some crypto. There's some additional hidden things in it. And then once you're done with all of that, you have to build your own database with some of the values that you pulled out of the initial database. So lots and lots of stuff is involved in this challenge, many, many steps. And if you did any of them wrong along the way, it could break the entire thing. So total nightmare. Probably should have been worth 1,000 points. But anyway, let's go ahead and jump in. All right. So all we have to do is unzip the MovieSQL zip, and we'll get rid of the zip now. And what we could do is attempt to try and extract this. Obviously, it's not that easy to get the flag. It does require a password. This one is absolutely a database. You could file the database. You can also double click it in Kali and it will open up SQLite or what is better known as the DB browser for SQLite. That'll expose the tables that are inside here. You can go to browse data. Under browse data, you can go into any one of the table rows and then see what values exist within there. And as you're looking at it, just as an example, encoded pass, you'll see the value that's encoded. I also gave you exactly what the encoding type is. So not rocket science when it comes down to that. However, one of the ones that is tricky is the encrypted one because it's not encoding. You have to know how to reverse that, how to decrypt it. All right, so some command line syntax will be required. Now, this is a teaching conference, so I am not going to use the GUI. You would absolutely be fine to use the graphical user interface to extract all of the data, except you're not going to get all of the data out of it. And I'll show you, I hid an additional value. If you got stuck in this sort of like tunnel vision of everything is inside this database, you would definitely miss the last value, which actually ended up getting appended to the back end of the database, just as a loose binary copy. But I'm going to walk you through how to do this through the CLI, just because that's what we do. We teach. All right. So first of all we're going to have to do is open up SQLite. We could do a version check real quick. See, I'm using 3461. But you can just do SQLite 3 and then create or specify which database you want to open. So in this case, we're going to open the Terminator DB. We are now inside Terminator. The first thing you'd probably want to do once you're inside a database is understand what tables. Remember when we double clicked it in the GUI, it showed us all those tables nice and presented, but we can just do type dot tables, and that will show you all of those same tables inside the database. So we have customers, employees, encrypted, orders, unzip key, DB header, encoded pass, HTH, CTF, and products. So what we can do is we can just then do select star from, and we can say like customers. And doesn't look like there's anything interesting in here. This is just a rabbit hole, just extra data in here. We could do select star from employees. Oops, forgot the semicolon. That's a gotcha. If this comes up for you, just note that you forgot to terminate the end of that command. It didn't know that you were done, right? So you have to put a semicolon. All right, so there's nothing again interesting in the employees row. Let's go ahead and do select star from encrypted. And again, I just totally forgot the semicolon. All right, so in here, what we see is there's that encrypted value, and again, the next column in that row, which is separated by that pipe, is telling you that it is OpenSSL AES 256-bit CBC salt and pass is required, right? So what we could do is we could just copy this text right here and go the hard way and hit copy, right? And then we could even open up another shell, and we could say echo, and then paste that into encrypted or something like that dot text. um, but I also want to show you how to do this inside a database, so you don't have to echo it to a file. You don't have to create a new text file and then paste it in. You can do it right from within the database to a file. So I tried to make that something you had to do in here because I actually added stuff into the database that was so large that there's no way to do it otherwise. But of course, from within the GUI, you can just copy it and you don't have to worry about doing it from command line. Where's the fun in that, right? So what we'll do is by the way, you can just hit up. It has, you can take advantage of the history. Hit tables again. There's nothing in orders. I'll just tell you that now. There's nothing in products. So the next one would be like unzip key. Well, I can't say there's nothing in it. There's just nothing for the CTF, right? So select star from unzip key. And cool. All right. So it's decently long. That's not the one I was talking about. Header, DB header is the one that's really, really long. But if we want to write this out to a file, all we have to do is do sorry, dot output and then give it an output name, right? So what do we want to call it? So we'll call it unzip key dot text. And as soon as I hit enter, you'll notice unzip key pops up here. It's ready to write. So this time I'm going to hit up and I'm going to say select from star from unzip key. And when I hit enter, it doesn't display it to the screen because it's putting it into the file. And then the last thing I want to do actually is tell it to not put it in the file, because now I want to see output on the screen. So we could just do output, and then we have to just tell it standard out again, right? So once we do that, now when we run a command again, it'll be displaying back to the screen. But let's go ahead and open up unzip. Cool. We notice that it is base 64 encoded. We'll just go ahead and take the front off and the back off so it'll decode properly. We'll hit save. Let's open up another terminal again. And then we already know it's base 64 encoded, so we can just say base 64 decode, and we're going to do unzip key, and just take a look at what it is. If I do that, we can see that it really is like a list of directions of things I need to do next as part of this. So as you can see, I kind of already had it set up to go ahead and pipe into directions. So that's what we'll output it to. We can now remove unzip key. We don't need it anymore because we have the directions in here. Cool. Close without saving. All right. So clearly I need more data to finish this out, because inside the directions, it's talking about needing some additional values and such. So we're just going to leave that for right now. We'll come back to it in a minute. Let's go back to our database. Minimize that for clarity. All right. So let's see the tables again one more time. All right, cool. So we got unzip key, we got encrypted. We do need DB headers. And again, if we do select star from DB header and then hit semicolon, you'll see it's very large this time. And so again, my goal here was to hope that you would see how to, or look up ways to output this to a file, right? So and this time we're gonna do output header.txt. There it is. And we just dumped it to the file. Now we'll do output back to standard out. All right, let's take a look at header. Okay, so we don't need the front, and let's go to the back and see. All right, so this is hex encoded. So let's go ahead and clean off the back, save it. Let's open up our other terminal again. All right, so in this case, what we can do is we can go ahead and do cat header, and then let's just do an XXD. We're going to reverse it back to plain text, and we're going to pipe it out to something. We don't know what it is. It's hex encoded. Let's drop it out there. It was definitely a lot of data. Let's file something, see what that is. It is a PNG, so we can move something to something.png. All right, what do we got? We can also remove the header file. All right, so if we open the PNG, you'll see that I'm telling you that I want a specific header for this SQLite database. If you are, for example, using SQLite version whatever, and it's different than the one I built the CTF on, the hashes are not going to match because the header version is in, or the version of SQL is actually in the front of the header. So in order to make this CTF actually work, it is a requirement that you have to modify the header in a hex editor, unless, of course, you're using the version that I used, which is, I believe, an older version than what's available now, right? So more than likely, you had to change the header. If you didn't have to change the header, that's awesome for you, saved you an extra step, but more than likely, you were going to have to modify the header. So this will be used later. We'll put that away for now and go back to extracting data out of this database. All right, so let's do tables again one more time. All right, we have the header. Now we need encoded pass. So select star from coded, encoded, coded. That's weird. Pass. And we get a base 64 value here. So we'll just copy that. I'm just going to copy that one just for the sake of ease. We'll echo that encoded pass, and we'll go ahead and say decode that, and I'm going to put it into password.text because it said it was encoded password, so I'm just going to call it password.text. Cool. Let's take a look at what that is. So we'll cat password. The password is it can't be reasoned with. Cool. All right, so it takes care of that. All right, next one is HTHCTF. So we'll do a select star from HTHCTF, and it's not anything useful actually either. This is just the creator of this challenge. And there's nothing in products. So we have everything that is actually inside the database. So if you're still digging around in the database, believe it or not, there's nothing else in there for you to grab. At this point, we can do .quit. And let's go to our instructions. All right, so in here, we have beginning of file, note case matters. Sure. All right, so what we want to do is create a database. Name apparently doesn't matter, and that is correct because all we're going to do at the end is hash it. You'll see that in a minute. We're going to create a table, and we're going to create a table called flag. Inside that table flag, we want two rows. We want one that's ID, and we're going to make that ID an integer, also a primary key, and we want it to auto increment. And the next row will be a key, or it's called key, and we want that key value in that row to be text. And then next thing it says is get solve string and new password. Well, we haven't seen anything called solve string yet. I don't know where that is. And we don't know where new password is. We had a password, but it's not like called new or anything. But apparently these two elements are still in Terminator DB. Like, that's interesting. Yeah, very interesting. All right, so let's keep reading this. So, all right, and then we need to re-encrypt the plain text solve string, which we don't have, with the exact command below, and replacing solve string and new password with the actual values. All right, so here's the command, echo solve string, which is just a variable placeholder. We're going to pipe that into OpenSSL, and we're going to use AES 256 CBC. And then, of course, we're going to do -A, -K, whatever those things are doing, right? And then we're going to echo a new password, whatever that new password is. So we're going to use that. And then we're going to pipe that into OpenSSL. We're going to use digest SHA-256, do some awk magic. We're going to do initialization vector, and we're going to say no salt. All right. So the hint with this is that at some point you have to encrypt a value yourself. This is the challenge was intended to be, I want you to understand the pain that I go through when I build these challenges. So I built the first database and I encrypted a value to put it in there. I now want you to know how to encrypt a value like I just did and how to create a database. So this should have been a hint based on this command that not only is this command used to encrypt that value, but it's also similar to the command I would have used to actually encrypt the initial value. Now, it's not the same for decrypting. And decrypting is a different command, but it's a hint for how to solve that as well. So then next, what we need to do is insert that encrypted solve string as key and like into that key row within the flag table. And then we need to close the database. We're going to change the DB header version to match the SQLite version 3461, which is the one I had. Remember from SQLite version, the dash dash version check. If you're already using 3461, congrats. Like I said, you don't need to modify the header, but most likely you will need to change that header with hex editor. And then we need to get the Blake 2. What the heck is Blake 2? Again, this is me trying to use obscure hashing algorithms or obscure compression algorithm, whatever. I always try and look for something obscure that maybe you've never heard of before. So yeah, you probably used or SHA, or sorry, like a MD5 hash or, some sort of hashing algorithm or, things like that to do this. In the past, Blake 2 is a totally different one. Shout out, by the way, to Soothsayer, who actually wrote a script to do Blake 2 when in fact it is actually built into Kali already. All you have to do is type in B2 and that utility will automatically do that. So like myself, way like overthinking things all the time. And of course, AI is our friend, and it also hurts us sometimes because if you ask AI to do that, it may give you a script. Whereas if you asked AI, hey, give me the easiest way to solve this in Kali Linux, it would have told you just type B2 with the hashing algorithm. In addition to that, we want to fold that hash into sets of 16 characters. If you didn't know this already, there is a utility in Linux called fold that will absolutely fold that for you. And then what we want to do is we'll get the flag zip unzipped here with the fifth set of 16 characters. So if you mess up anything along the way, any character at all, the hash will not match and you will not be able to unzip the flag. So that is what makes this challenge exceptionally painful because there's lots of steps that you could totally mess up along the way. So first of all, let's go ahead and perhaps encrypt. Well, we have to figure out where that, we have to figure out where the solve string is, right? So like I said, what we need to do is we need to actually cat the terminator DB. So if you've ever done any least significant bit work, guess what? You can append sort of a least significant bit to a database. All I did was echo a string essentially with, basically like two carets, into the database. But in this case, if you cat terminator DB, it's hard to read and your mind is probably already melting at this point. But this is hexadecimal. Down here is base 64. So somewhere in the middle we switch. So if we follow sort of the lines, you'll see, oh, it says hex right here. If you remember in the database, we had a value, and then I told you how to, what kind of encoding or encryption it was. So this is the value, and in the second column, this is how it's encoded. And that was the end of the database. And then I piped this in at the end, which is just base 64. So this is not actually in the database anywhere. It's just appended to the back end. So we'll take that, we'll echo that, and then we'll base 64 decode it. If we were just to do the decode like that, we would notice that it starts with a PK. PK, if you've done any hexadecimal or hex editing of files, you know PK is the magic editor for a zip file. Inside that zip file, there is a file called new password, and inside new password is the string come with me if you want to live. Now, we can play that all the way out just by doing the decode and piping it to newpass.zip. And we can file newpass.zip just to make sure. And yes, in fact, it is a zip file. We can then unzip newpass.zip and we can remove newpass.zip. We don't need it anymore. When we go into new password, which is what extracted out, by the way, it is come with me if you want to live, as we saw. So the zip was not encrypted. There's no password on it. And if it's not encrypted, you can see all that information in plain text. So definitely cool. All right. So we have come with me if you want to live, which is the new password. And we have what we're missing though is the solve string, right? What we do have though is an encrypted value. So we have this encrypted value here, which I'll copy. And we have the new password. And if you look at the command, this is the hint, right? So we need to echo this. So if I echo, actually, let me clear the screen so you can see it's easier. We echo this long string, and then we pipe it into OpenSSL and we do a decrypt. And again, we're doing AES 256 CBC. And then we're going to say, no salt, whatever. And with the password is it can't be reasoned with. Remember? So we saw password is it can't be reasoned with. Cool. All right. So when we hit enter on this, we get a solved string. And the solved string is Leet Terminator skills. Cool. So we'll echo that into solve string. Cool. We have it. So we don't need new password anymore. We actually don't need Terminator DB anymore. We're done with it. And we don't need encrypted because we've got everything out of encrypted. So we are now down to, we actually do need, sorry. We had, it can't be reasoned with as the way to extract that, but we do need new password. Sorry. Let me restore that one. My bad. All right. So we still have to figure out what to do with new password, which has come with me if you want to live. All right, cool. All right, so looking at the directions, it says, we need to create the table. I'll do that here in a minute. Let's figure out how to get this string encrypted. So now we have the solve string and we do have the new password. So let's just run this command with those values in it. So all I'm gonna do is just gonna come with me if you want to live. And that goes into here. There we go. And then the solve string, which is Leet Terminator skills. And that'll go right here. Cool. And then what we'll do is, let's do this. All right, cool. Let's copy this entire line and paste. Cool. All right, so that encrypted a string, and this is the only string you should have gotten, which is right here. It starts with 4DQ and ends in an equal, so that is the correct one. Fun fact, if you do not specify no salt, and then do the IV clearing of the IV, what it'll do, OpenSSL will generate a unique value every time. So it'll work, and you'll think, oh, cool, I got it. But it actually is creating a very unique value every time because it's creating a new initialization vector as salt. So that's why you have to specify that, or it will give you a different value. So this is the only way to get the right value. All right, cool. So we have the value. This is going to be, we'll call it basically the new key value. So we'll just echo this. Actually, let me put that in quotes. To new encrypted, sure. There we go. All right, so now we don't need New password. We're done with it. We don't need password anymore. We're done with it. And we don't need the solve string. We are getting down to the nitty gritty. Okay, so cool. All right, so now we have to create this new database, right? And we have to create a table called flag, and we have to add ID and key as rows. So I definitely wanted you to do this via command line. I didn't even like really kind of think through what if someone does this through the GUI and it's different. I assume that you could just use the GUI and everything would be fine. However, there are some differences between the graphical user interface and the command line. We're going to go over that here in a minute, but first I'm going to show you how to solve it via CLI, so you know how to do that. So to create a new database, all we do is type in SQLite 3, and we have to give it a database name. So we'll call it HTH database. Notice it doesn't write anything out until we've actually written something to it. The next thing we need to do is say create, and we want to create a table. We want to call that table flag, and we need to add some rows inside the table. One is ID, and that is a integer. It is also going to be a primary key. We want it to auto increment. That's something we said we wanted it to do. It's written up here as the instructions. So that's how you know how to do that. The next thing is we need in the next row, we need a key and as the row. And we want that to be text. And that is all you have to do to create the table. The next thing is we need to insert, according to this, the new encrypted value inside of the key row. Cool. All right, so new encrypted is right here. Copy that guy. And then how we do that is we just type in insert, and then we want to say into table flag, the row key, and the values, and then we'll put in there the value, and boom. All right, cool. All right, so that is done. Now we just have to quit. And that is that. Cool. Now, my version of SQL was already 3461, so there's no reason for me to modify the header. However, if you needed to modify the header, of course, you would do a hex editor and HTH, and then you can modify it. So here's the image of my header. If you were going to modify it, you literally just type in here 5351 4C. Oops. Hopes if you get that one right. 4C. And then, finish it out the rest of the way. And, may have to do the next couple of lines a little bit, but, you get there, save the file, and we are good to go. Cool. Now we just have to follow the rest of the directions, which in this case is get the Blake2 hash value and fold it into sets of 16. So we'll do a B2 sum of HTHDB, and we're going to fold it into 16 sets. So when we do that, it done folded it into 16. So in here, we said that the fifth set of 16 characters is the one that's used to unzip the password, or is the password for unzipping the flag. So this is the first one, second one, third one, fourth one, fifth one. So this is the password here. Let's go ahead and try that. Unzip flag.zip, enter, and let's paste the password in. And it is done. So flag.text popped up. The flag is HTH John and Sarah in targets DB. So that is how you solve this challenge. All right, so stick around with me here as we dive into the wonderful world and differences of the SQL for the GUI. So what I'm going to do first is I'm going to open up the HTHDB so you can see what that looks like. Inside there, you'll see the flag, and then you're going to see, ID as an integer and key as text. Nothing crazy there. I'm actually going to close that out real quick. And then this time, let's open it up So if you're going to go under, SQLite browser, we can create a new one. So if we wanted to do that, we could say new database, and then, we'll call it hth2.db, and let's just put it in the same folder as MovieSQL. Cool, save. It opens up the edit table definition setup. So we have to call the table something. We're going to call it flag. And then we're going to add the field, which is ID. It is an integer. You can change it to something else. Integer. We want to make it a primary key, and we want it to auto increment. The GUI is a lot easier because you can just flip these things on. We also want to add another row, which is key, and it is or not an integer, a text piece, right? And notice as I'm filling this in, it's giving you the SQL code down below, which you could just paste into SQLite CLI, and it would work as well. Some differences you're going to notice right off the bat. Here's the difference. So SQLite is actually giving you quoted variables. I didn't quote mine in command line, and they're not necessary to use the quotes. And that is because I didn't care about the case sensitivity of the values at the time I was building it. Now I did have that note in there saying case matters. I was actually referring to something else entirely. I didn't realize that the quotes were going to break it. So this was a learning curve for me. So technically it's solvable, but also if you use the graphical user interface, it was never going to work ever to begin with. So I learned something new through this process. This is a learning conference. So I'm going to count this as a win anyway. But essentially, when you hit OK on that, it actually will create that database with that information in there with quotes. You'll also notice that when it does this, that it actually changes the order of some of the stuff in here. So ID integer and key, some of that just gets changed around a little bit. So if I open up the other one and we take a look at the differences, you'll see that it does, put in some commas and, changes the order. So, and if you change a single character in that, it's going to absolutely manipulate the hash in a way that isn't going to line up. So both are technically correct. Both will work. But, I intended it to only be done the one way. And it got through QA because what I had told the debuggers was that we're going to do this all through CLI. Didn't really think that it would change anything going into the graphical user interface. But again, we did learn something new off that. So it still works. It's a learning conference. We're going to count it as a win. However, in the future, I'm just going to note that as a pitfall so you don't get stuck on that intentionally. That's not something I tried to do just to get you hung up. So, all right. Well, cool. That is how you solve MovieSQL. I hope you enjoyed and learned a little something new. We'll catch you next time.